All right, so we can also use a function to solve for a value. So you'll notice here that I've given a graph on a line. You'll notice that the y-intercept is somewhere between -3 and -4. So it's going to be, we're going to have to use slope point form in order to solve x minus x1 plus y1. I'm going to have to use that to create our equation, and we can always put it into graphic form later on if we need. So first of all, we want to determine the equation of the function. We need to know a point right there, x1, y1, and we need to know our slope, rise over run. So we're going to start with our slope. Oh, gotta go all the way down to there. We're going to have a negative slope here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11 over 1, 2, 3, 4 over 4. So our slope, negative 11 over 4. We have 2 points. We have the point here, -3, 5, and 1, -6. Both of them are going to have some negatives in there, which doesn't really matter. I'm going to use this point here, -3, 5, for the point to create the equation. So y is equal to -11 over 4, x plus 3 plus 5. And that's going to give us our equation. Now again, we could do both if we really wanted to. Y is equal to -11 over 4, x minus 1 minus 6. Both of them work. Either or. Doesn't matter. You can do either or on a test or a weekly progress check or an assignment. Both of them will work, and I try to have both of the answers in the answer key as well. Now, let's determine the value of y when x is 100. Well, we can use either one, remember. X is 100. So we're going to take y is equal to -11 over 4, 100 plus 3 plus 5. Okay, so you notice that I replaced the x right here with 100. Now all we need to do is solve. Okay, and what we can do if we really want to is just type this whole thing into our calculators, -11 over 4 times, I'm going to open up my brackets, 100 plus 3, close brackets, plus 5. And it gives me an answer of -278 and a quarter, or -278.25. So our point here is at 100, -278 and a quarter, okay, or 0.25. That would be the point where x is when x is 100. What about the y-intercept of the graph? You'll notice here it's somewhere around -3, just above -3 or just below -3. Can we solve for that? Well, of course. The x-intercept, the y-intercept is when x equals 0. Okay, so y is equal to -11 over 4, 0 plus 3 plus 5. Again, we can go through, so this is like 3, multiply this by 3, then add 5 to it. You could do that, or -11 over 4 times 0 plus 3 plus 5. And our y-intercept is at -3 and a quarter, okay, which makes about sense. This is about 0 and -3 and a quarter. Okay, that would be roughly the point that we are at. Okay, looks pretty good. To be honest, we probably did it correctly that way. Okay, but we use x is equal to 0. Now let's convert this equation to graphic form. We know the y-intercept, but I want to use the conversion method to show that it is in fact exactly that. -11 over 4, x plus 3 plus 5. Okay, I'm going to do both of them again just to show that it creates the exact same equation. We multiply into the brackets. This is y is equal to -11 over 4, x minus 33 over 4 plus 5. 33 over 4 would be like 8 and 1/4, -8 and a quarter. So we're going to add these two terms together right here. -33 over 4 plus 5 is -3 and a quarter. Y equals -11 over a quarter x minus 3 and a quarter. Sorry, 11 fourths, I should say. Not 11 and a quarter, 11 fourths. Okay, so this would be our answer in graphic form. Again, we get our y-intercept, which we already knew. but it's always good to solve for it still as well. All right, 11 over 4x minus 1. This is our other one here that we can do. I'll put that on there. This is bonus material for those of you in my class. I like doing bonus material apparently. Plus 11 over 4 minus 6. Y is equal to negative 11 over 4x. And then 11 over 4 minus 6 is what we would expect, 3 1/4. Okay. So we get the exact same result from it, which is what we want. It's what we expect. Okay, but either one gives us the same value in graphic form. All right, solving a contextual problem. A contextual problem can be written as an equation as well. We first of all need to define the variables based on the unknowns of the contextual problem, and then determine the slope between the 2 points if the slope is not given. Again, remember that this is important here. Our slope is our rate of change. Okay. Then enter the values into the form. If we're going to use graphic form, we use graphic form. If we use slope-intercept form, we use slope-intercept form. If we use graphic form or slope point form. Slope point form is the other one. Okay. Then we would do that. Okay, and then give the domain and range of the scenario. So let's use an example here. Now, a temperature in degrees Celsius is a linear function of the temperature in degrees Fahrenheit. Paul knows that the boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit, and he also sees that negative 40 Celsius is negative 40 Fahrenheit. Okay, let's write a linear equation to show the linear relationship between degrees Celsius and degrees Fahrenheit. Now, our two unknowns here, our x and our y, are going to be the degrees Celsius and degrees Fahrenheit. Okay, so x is going to be our value in degrees Celsius, y is going to be degrees Fahrenheit. Our points that we have here are 100 to 12. Okay, Celsius, Fahrenheit, these are like equal. And we also have negative 40, negative 40. Those are going to be our 2 points that we have. We need to create an equation. So what we're going to do is, the first thing we do is find the slope. M equals y2 minus y1 over x2 minus x1, because their numbers are a little bit bigger. So we're going to do 212 minus negative 40 and 100 minus negative 40. And this is going to give us a slope of 252 over 140. And we can simplify that. Okay, 252 over 140 is 9 over 5. Okay, so there's our slope. Now again, I'm using my slope formula because I just have 2 points. We can use either one of these 2 points now that we have our slope. Y is equal to 9 over 5, x minus 100 plus 212, or y is equal to 9 over 5, x plus 40 minus 40. Those will be our 2 equations using slope point form. And again, we can do that because we have our slope, which we found, and we have a point. Now, we need to know at least 1 point, and if we know 2, then there's 2 different kinds that we can do. All right, let's convert this equation into graphic form. I'm going to take the first one there, 9 over 5, x minus 100 plus 212. Multiply it through, 9 over 5x minus 900 over 5 plus 212. 900 over 5 is 180. So y is equal to 9 over 5x minus 180 plus 212. And when we combine those two, 9 over 5x plus 32. Okay, so that would be our equation in graphic form. Now again, we can do the same thing with this one here. It's going to give us our exact same value. Just kind of go with it. You can look at the previous example if you want to see that both ways do in fact work. Now let's say iron melts at 2,795 degrees Fahrenheit. Determine the temperature in degrees Celsius. Well, degrees Fahrenheit, if we go back up here, is our Y. So we know that Y is equal to 2795 degrees Fahrenheit. Plug that in. 2795 is equal to 9 over 5x plus 32. I'm going to use my graphic form, even though I should probably use the other one, but this is definitely easier. 2795 minus 32. 2763 is equal to 9 over 5x. There's a couple different ways that we can now solve this. We can either multiply both sides by 5 and then divide by 9, or we can just divide by 9 over 5. I'm going to divide by 9 over 5. And x is equal to, divided by 9 over 5. 1535 degrees Celsius. So iron melts at 1535 degrees Celsius. All right, now again, for those of you following along in class, your assignment is LI 0.05. Numbers, what was I going to do? 5 to 7. And then we will do one more lesson and go over one more assignment.